Hello and welcome to this ISDA webinar on the ISDA Common Domain Model 1.0. My name is Clive Ansell. I'm Head of Market Infrastructure and Technology here at ISDA. So for anyone who has followed this initiative closely, you may recall that in 2017, ISDA embarked on a project to develop the ISDA Common Domain Model, or the ISDA CDM. Essentially, a common, robust digital blueprint for how derivatives are traded and managed across their life cycle. It is designed to provide a foundational standard upon which existing and emerging technologies such as AI, cloud, distributed ledger and smart contracts can be exploited. These common standards aim to enable and/or accelerate greater automation and efficiency in the derivatives market, while facilitating interoperability across firms and platforms. In this webinar, we will provide an overview of ISDA CDM 1.0, the first digital representation of the model, which was released at the beginning of June. My colleague, Rudy Vincent, will walk us through the model using a visual representation, describing its basic structure and how it works. By publishing this initial baseline, ISDA is looking for feedback and validation from market participants in order to refine and extend the model. In addition, as part of this feedback phase, ISDA also anticipates working on proof of concepts to demonstrate the various applications of CDM to help solve current industry challenges. I'll tell you a bit more about this later, but for now, I'll hand over to Rudy.
Thank you, Clive. Good morning and good afternoon for some. So my name is Rudy Vincent. I'm an Assistant Director here at ISDA within the Market Infrastructure and Technology. So talking about the ISDA CDM 1.0, I think what would be of order first is to show you a little bit where you can find it. So most recently, earlier in June 2008, ISDA has made this first snapshot of the ISDA CDM 1.0 available on the ISDA website. So if you allow me just to navigate very quickly to that web page, I can show you what I'm referring to. So if you access ISDA.org, it will either lead you to the main page where you can find a reference to ISDA CDM 1.0, or if you navigate within the infrastructure section, similarly, it will lead you there. What you will then find is a web page effectively giving you a very quick description of the ISDA CDM 1.0 and the contents of the package that I'm just going to explain in a second. So that package is effectively in two main parts. The compressed part, which contains a digital representation of the model, as well as some supporting materials that give you some insight on the approach that we have taken to build the model, both from human readable format as well as some Java classes and compile classes that allow you to perhaps use the model in a testing fashion. And that's very much what we want to emphasize. The ISDA CDM 1.0 is first seeking feedback from the industry, from you, to help us orient the efforts and making sure that we are building a standardized representations of product and events that is of use for the industry. Now, the package itself, what does it contain? Well, it will have the core representations of the model in a human-readable format that you can actually, with some knowledge of derivative products, you'll be able to navigate through and understand how we have built it. In addition to that, the package will also have a data file machine-readable formats. That's what we call JSON, JavaScript Object Notations. This representation can be useful if you were to bring the model to interact with some level of infrastructure. Finally, the third part, the last two parts are, as I mentioned, the automatically generated source codes in Java that you can actually use as part of test platform and the corresponding documentation. Now, to help understand how we've built the models, we've also provided some projections of trade representations for interest rate derivative product and credit derivative products in JSON format. So we've leveraged some FPML trade data and we've converted them into JSON CDM formats, which then help illustrate how we have effectively structured the representing these different products and these different events. Within the package, you will also find some interesting detailed documentation that I would also invite you, in addition to the supporting material, to consult. Now, that's pretty much the content of the package itself, but what I'd like to do is use this opportunity to show you a little bit more how the model looks like and the approach that we've taken. So if you allow me then to navigate through to the Rosetta portal, which is a platform that we're working with, developed by the Regnosis technology consulting team that we are using here at ISDA as part of this effort. And to understand really how the model is built, what I can do is first of all explain a little bit where it's been the scope. We focused on products, derivative products, yes, interest rates and a credit default derivative products. And you can actually recognize that when you scrutinize this simple product, you're looking at cash flows between parties. And at the most granular level, our objective has been to recognize what are the commonalities between the mechanics of a CDS and the mechanic of an interest rate. Also recognize what are the commonalities with options, CDS option and interest rate options. And when you decompose these different products and look at a float to a fixed float, at the end of the day, you will find that the float is a cash flow that is calculated on the back of a floating benchmark. A fixed float derivative product is also calculated on the same mechanics, only that is calculated on the back of a fixed rate and a floating rate for floating leg. When you consider a CDS product, you will have a protection leg with the corresponding cash flow and a floating leg that will have the cash flow calculated on the back of a benchmark, similarly. So this is very much what we've focused on. Decompose those different products, recognize the common mechanics, and acknowledge how you can assemble these different components to reconstruct your product. Allow me to illustrate that by using the graphical navigation of the model and focusing particularly on contracts. So I'm just going to effectively show you, this is the graphical representations when we start at a contract level. We've looked at the contract we start looking at contract from a legal perspective and recognizing the different parties. But rather than looking at some of the detail that perhaps can be looked at in the different occasions, what I wanted to link back to is this different set of mechanics. And this is encapsulated within what we call the contractual products, which is a component of the contract. The contractual products encapsulate both the economic terms as well as the product identification and the product taxonomy. We're currently working with ISDA version 2 taxonomy. The economic terms themselves are effectively regrouped in two major sets. First, the legal provision, cancelable provision, early terminations, and extendable provisions, as well as the payout classes. And this is very much the crux of this product model. The payout classes are corresponding to these different mechanics that are described. You will have the mechanics of an interest rate payout class, which effectively calculates the cash flow based on a rate. That rate can be fixed for a fixed leg. That rate can vary for a floating leg. You will have the credit default payout class, which effectively calculates the cash flow from the production term. You will also have a simple mechanics that can issue a fee or a payment or bullet payments. Finally, we wanted to introduce the concept of option for CDS options and interest rate swap options. So similarly, with the option payout class, we are capturing the mechanics that for an option derivative product, which has an underlier that effectively will point back to a contractual product, which itself is described by its economic terms, and its economic term is can be composed of different sets of payout classes. These payout classes can be a set of cash flow, it can be a credit default payout class or a credit default payout protection leg, it can be a floating leg for an interest rate payout, or it can also go back even further down. And without necessarily going into all the details, I really wanted to clearly demonstrate the potential for the CDM, which is by having recognized those different building blocks, cash flow, credit default payout, interest rate payout, as well as option payout, we are enabling ourselves to recompose those complex products that we wanted to manipulate, such as CDS and interest rate derivative products. Now, what I can do is also focus on the second dimension of the model, that is the event model. As I mentioned, looking at the products, we've also looked at the events. We've agreed to a defined set of events that we would scrutinize, such as allocation, compression, novation, partial terminations. And we do recognize that, to our knowledge, there isn't an established industry standards for representing business events. So our approach has been similar to products. By looking at the most granular level, what's happening on the back of a business event, we've effectively allowed ourselves to build the tools to reconstruct complex events. To illustrate this, I can perhaps talk about partial termination. A partial terminations, you can consider it as just a combination of two actions: a notional revision, as well as potentially a payment being issued as a fee. So at the most granular level, you've got two actions to be done. Now, you could consider novations and recognize that the novations will lead to a new contract being instantiated. And if it was a partial terminations, you may have a revision of the old transactions in regard to the corresponding notional. So our objective is to, by decomposing all those business events, recognize the most basic actions, the most primitive events that will make up the fabric of business events, and hopefully by extensions, business processes. The graphical representation that I'm currently showing is indeed looking at an event and highlighting that an event can be made, will involve different set of parties and will be made of a set of primitives. Our first iterations has looked at primitive events such as allocation, exercise, new trades, observation of a quantity, or the term change, which you may associate to a simple amendment, party change, which you could associate to a novation or an intermediation, payments, which can be associated to the issuance of a bullet payment, for example, quantity change that I illustrated by using the example of a partial terminations, and a reset that would effectively reset the fixing rate for enabling you to calculate a floating amount, for example. Now, you would say, what are those primitive events? What are they made of? Well, looking at a simple case, which is a quantity change, our approach looking at business events and looking at them from a most primitive level, the most basic level, an event is a transition from a before state to an after state with a description of what is effectively changing. The before state itself is actually a contract, or it can also be a contract reference. If you're working, for example, with cloud technology, or perhaps with more advanced technology, and I think there's been reference to distributed ledger technology, the after state will also be a contract or a contract reference. You're going from a contract, say you're doing a partial termination, you started with a contract, you've done a partial termination, you still have your contract at the end with a notional that has changed, and that's what we've captured. We are looking at different set of changes potentially for now, just a simple scalar change for the notional, and different types of notional changes per the product that we will be looking at. So our objective is to consistently represent these different primitives as a combination of before, after, and change across the board. If by having these elementary building blocks, we are then able to recompose different set of look at the fabric of more complex business events, as I mentioned about allocation, compression, termination, exercise, increase, novation, terminations. So it is our objective to be able to infer different set of events per the fabric or primitive event that they're using. Now, what I'd like to do is to touch base on the third dimension of the model, or the third dimension of our most recent efforts, which is to illustrate how you can use the model. And for that intent, we've looked at the ISDA definition for rate calculations, particularly for fixed amount and floating amount. So when you look at the detailed core human readable description of the model, and this is very much a core CDM, and if you were to focus on fixed amounts, how do we model fixed amounts? How do we model floating amount? How do we model day count fraction? Some may say these are textbook examples and they've been they are well understood by the industry. Well, our intent here is to demonstrate that you can go from a legal textual definition of a fixed amount and articulate the explicit formula that will allow you to calculate what is this fixed amount and what does it depend on. Here, the fixed amount is simply the multiplication of 3 parameters. These 3 parameters, you will then say, what are they? How do I know what information to use? Well, the model is able, having this looked at it from the most granular level, we're able to tell you that the calculation amount is pointing at this particular address within the model, within the interest payout class, navigating through the quantity, notional schedule, notional step schedule, and initial value. The currency amount similarly, the rate similarly, while the day count fractions as well. In the same fashion, the floating amount, which has a legal text description per the ISDA definition, can similarly be articulated with the same formula, similar formula, and we can explicitly point you to the data point that you will need to use for calculating this floating amount. So assuming that you've effectively implemented a database per the CDM, you should end up with the same amount if you use that particular formula. Granted, there may be some caveat in relation to the data points the origin of your data point in terms of data sources, but if you apply the same formula, there is little reason why you shouldn't get the same number. Just as another illustrations, when you look at the day count fractions, we've effectively explicitly articulated what is the 30 over 360. This is very simple formula, which effectively pointing a different set of data points in the model as illustrated below. So with this example, I'm effectively trying to show to you that the model is able to turn legal complex description into explicit articulated formula that will allow you, if you implement per the CDM and you have your counterparty implementing per the CDM in the data model as well as calculation, it will help you to iron out breaks in what number you are both coming up with. And perhaps this is setting the scene very much for concepts in terms of removing breaks in terms of your reconciliation, but also potentially turning legal documentation into smart contract. But I propose to pause here and just hand back to Clyde.
Thanks, Rudy. So we hope that's provided you with a good understanding of what is the CDM 1.0 is, even if for some it may have appeared to be a bit technical at times. We will be releasing more materials over time to suit various audiences. This is an important, ambitious project, and we believe it has huge potential to bring significant benefits to our market. As I mentioned at the start, we are opening up our development process to user testing, and we will be working on proofs of concept to demonstrate CDM applications. Now, it's vital that we receive feedback from across all sectors of the market in order to build a robust and useful model. If you'd like to get more involved in the process, please contact Market Infrastructure and Technology at ISDA.org or join the ISDA CDM Design Working Group. I'd like to thank you for your time today. Please don't hesitate to get in touch if you need to know more.
Thank you.